Welcome back to Jackson Square. Today we'll be looking at locating and comparing rational numbers. This is TEK 6.2c, which says I can locate, compare, and order integers and rational numbers using a number line. So let's jump right in. First, we need to know that each number belongs in a specific location on the number line. So I'm going to show you how to plot a point on the number line and how we can use certain strategies to locate it. So our first number is -8 and 7/10. So I'm going to go to my negative side, and -8 and 7/10 would be in between -8 and -9. Because it's 7/10, it will be closer to the 9 than to the 8. So I'm going to put a dot here, and you can do two things. For this example, you can label it with letters because we have letters, or you can write in the actual number. I'm going to label it with letters for this example, so I know that this is the -8 and 7/10 location. Our next number is 5 and 6/10. That's positive, so I go to my positive side. 5 and 6/10 will be in between 5 and 6. It will be closer to the 6, so I'll put my dot there and label it B. C is -1 and 1/10. Again, I go back to my negative side. -1 and 1/10 will be in between -1 and -2. It's going to be closer to -1. So these are about approximations. Since we don't have tick marks in between, we're just making estimations. Again, while I'm saying closer to this number than that number based on what is behind the decimal point. Here we have 3.4. 3.4 will be in between 3 and 4. Will it be closer to 3 or 4? Closer to 3. And last, we have 9.3. So 9.3 would be in between 9 and 10 and closer to the 10. So this is how you can locate points and plot them on a number line. So we're going to do a few more examples. I'm going to jump down to conversions and then jump back up to do some other ordering, okay? So the first thing we need to know is we have all types of rational numbers. Remember, we've talked about whole numbers, integers. We know about terminating decimals, about repeating decimals, mixed numbers, and proper. So you're going to see all of these things again. Remember how to classify those things, and we're going to have to convert them. So remember, we are building, okay? Everything that we've learning this year, we are building on top of it. So we can't leave anything behind. So we need to bring those skills from chapter 2 back on converting fractions, decimals, and percents to be able to be successful in this unit. So the next section that we're going to look at is percents. It says percents can also be ordered, but they must be converted to decimals because decimals are just friendlier, right? Convert a percent to a decimal by moving the decimal 2 places to the left. So we're going to be converting all of these to decimals by moving them 2 places to the left. And once I move them those 2 places to the left, then I'll take the time to place them on the number line. So here, the first percent we have is 188%. We would take the decimal, which is back here, and move it 2 places, 1, 2. This will become 1 and 88 hundredths. 68%, 1, 2, will become 68 hundredths. 9/10%. Still moving in 2 places to the left, 1, 2. We'd have to put a placeholder. This will become 9 thousandths, okay? 33.3%. Again, move it 1, 2. We would simplify this as 33 hundredths. We know that that is a repeating decimal. You see the bar over the 3, so we can do that. So now we've converted everything to a decimal, and hopefully this was easy because we've done it before. And this time, because I don't have letters, I'm going to label the number line with the actual number. So sometimes I may go above and below just so that it doesn't look a bit crowded. So we're going to start with 1 and 88 hundredths. So we know that 1 and 88 hundredths would be between 1 and 2. Again, it would be closer to the 2. So I'm going to label with the original number, which was the percentage. So that's something we have to remember when we are given our original number and we convert it. We're converting it to make it friendly for us to be able to put it on the number line. But then when you put it on the number line, use the original form. So remember to always put it back in the original form. 68% or 68 hundredths, that is less than 1. It's going to be between 0 and 1, closer to the 1. This may be a little bit too far over, but it's okay. Then we have 9 thousandths. 9 thousandths is teeny tiny little bitty crumb. So it's going to be almost super close to 0. Not almost super close, it's going to be super close to 0. So that will give us our 0.9%. And then last we have 33.3%, which we know is less than 1. It is less than 50%. So we would imagine maybe this is our half. It would be about here, maybe closer, not as close to the 0.9%, but not as close to the 68% as well. So I'll put that one at the bottom. So these are our numbers on the number line. We took our percents, converted them to decimals, moved them 2 places to the left, and then we put them on the number line. So we want to make sure that we have good understanding of where those numbers would fall. You know, if they would be in between 0 and 1, if it'd be greater than 1 and 2. So we're locating and we're comparing during this particular part of the TEK. So we want to focus on locating. Okay, on this problem, it says the following numbers are placed on a number line. Which of the following best represents point A? So we're looking at point A. We're not worried about D and C, so don't lose focus looking other places. We are looking at point A. So we want to use our knowledge of number lines to figure out which one this could be. So we can eliminate some of these choices by hopefully just things that we know. So let's look at point A. First of all, point A is in between -1 and -2. It's in between -1 and -2. It's on the negative side. So since it's on the negative side, and I'm looking at my choices, I have negative, 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 positive. So I know it's not D because D is positive. So then it's in between -1 and -2. So I have -2/3, -2 2/3, -1 1/3. It's definitely not -2 2/3 because that would be behind here, okay? So I can eliminate B. So then it leaves me with -2/3 and -1 1/3. Well, -2/3, hopefully you know, would be -66 hundredths. 66 hundredths is less than -1. So -2/3 would be somewhere in this area. So I can cancel out A. So just by process of elimination, I know that this has to be -1 1/3. And if you take a closer look, we'll see that it's broken into thirds. Here's 1 section, 2 section, 3 sections. So if this is 1, 2, 3, this is the first section behind -1, which would be the -1/3. So that's how you can locate and you can compare where your numbers are on the number line just using what we know. The money in Mrs. Finch's savings account is earning 1 4,500% interest. Which number below is greater than 1 4,500%? So we want a number that is greater. Okay? So just like before, the first thing I want to do is take this percentage and make it a decimal. Look at all our answer choices. They're all in decimal form. To make it a decimal, we have to go 2 places to the left. 1, 2. So this would become 145 10,000ths, okay? 10,000ths, okay? 145 10,000ths. So when we are comparing, you want to look at place value. It's all about place value. So I'm going to take some of these numbers and try to line it up here. So here we have 9,000ths, but this number above is 10,000ths. So I'm going to add an extra zero so I can compare them. So if I'm looking at the first place or the 10th place, they're both zeros. So they're the same. But then when I get here to the hundreds place, I have a 1 and then I have a 0. So that means that the 1 is definitely larger than the 0. So in this comparison, again, we can also look at the last three numbers. My last two numbers are 145. Here, my last two numbers are 90. We're looking for a number that's greater than 145. So 90 is definitely not that. So I'm going to take that same strategy and I'm going to do it here, add zeros if I need. So that one needs a 0. This one does not. This one does not. It already has 4 places. So I know if anything has a 0 in the second, in the hundreds place, it's not going to be greater. So what else can I eliminate? This has a 1. This has a 0. So looking at those last 3 digits, that would be 32 10,000s. 32 10,000s is smaller than 145. So looking at the hundreds place, these are the ones that have 1s there. So let's compare those. I'm going to rewrite my number. So let's look at it one at a time. The tenths, they're all the same. The hundreds, they're all the same. Then we get here and we're looking for the thousands. Which number is bigger, 4, 9, or 1? Well, clearly we know the 9 is the largest. So based on the place value, I can tell that this number is larger, okay? And if we want to go back and look at those 3 places again, what's bigger, 117, 190, or 145? Definitely 190. And remember, we're looking for a number that's greater than 145. So the answer to this problem would be 190 10,000 is the larger number. So again, let's do a quick recap of what we have learned. We know that each number belongs in a specific location on a number line. We know that we want to make all of our numbers the same format. So if we have percent, we want to make them decimals. If we have fractions, we may want to make them decimals. Or if they're improper, we might want to make them mixed numbers. We want to make them something easy and friendly for us to use to be able to find out and to locate where they go on the number line. When we're comparing, it's all about the place value. We're looking at the tenths place, hundreds place, thousands place to see which number is less or greater, depending on what our question is asking us. So I hope that you've enjoyed this and it's easy. So let's practice.